An oxygen cylinder of volume 30 liter has 18.20 moles of oxygen. After some oxygen is withdrawn from the cylinder, its gauge pressure drops to 11 atmospheric pressure at temperature 27 degrees Celsius. The mass of oxygen withdrawn from the cylinder is nearly equal to, given that R is equal to 100 divided by 12 joule per mole Kelvin. Molecular mass of oxygen molecule is 32. 1 atmospheric pressure is equal to 1.01 10 to the power 5 Newton per meter square. The given options are option A 0.125 kilogram, option B 0.144 kilogram, option C 0.116 kilogram, option D 0.156 kilogram. We have given with the final pressure and the temperature of the oxygen cylinder. Therefore, we can solve this question by using the ideal gas equation, which is PV is equal to nRT, where P is the pressure of the oxygen and V is the volume of the container and V is the volume of the gas, N is the number of moles of the gas, R is the universal gas constant and T is the temperature of the gas. Here we have given with pressure, volume, R, that is the universal gas constant, and the temperature. So we have to find out the number of moles in the oxygen cylinder. To find out, we can rearrange the equation as N, number of moles, is equal to pressure, volume divided by R, universal gas constant, and temperature, PV divided by RT. We have given with pressure, P is equal to 11 atm, atmospheric pressure. Pressure of the oxygen after removing some amount of oxygen from the cylinder. Now moving to the volume of the gas. The volume V is given as 30 liter. But the SI unit of volume is meter cube. 1 meter cube is equal to 1000 liter. That is 1 liter is equal to 1 divided by 1000. It is equal to 10 to the power of minus 3 meter cube. So 30 liter of oxygen is equal to 30 multiplied by 10 to the power minus 3 meter cube, which gives V is equal to 0.03 meter cube. Now moving on to the temperature. From the question, the temperature is given as 27 degrees centigrade. This is also not in the SI unit. The SI unit of temperature is Kelvin. The relation between degree centigrade and Kelvin is 1 Kelvin is equal to degree centigrade plus 273. So the temperature in Kelvin is equal to 27 degree centigrade plus 273, which equals 300 Kelvin. Now the universal gas constant R is equal to 100 divided by 12 joule per mole Kelvin, as given in the question. Now we have to apply all the values in the above equation, that is N is equal to PV divided by RT, which gives the pressure P is 11 into 1.01 10 to the power 5 and V is equal to 0.03 meter cube, all divided by R is equal to 100 divided by 12 and the temperature is 300 Kelvin. So on simplifying, we get 11 into 1.01 10 raised to 3 divided by 125, which gives N is equal to 13.33 mole. We know that initially the oxygen cylinder contains 18.2 moles of oxygen. After removing some amount of oxygen, we got N final is equal to 13.33 moles. So the number of moles of oxygen removed, N is equal to 18.2 minus 13.33, which is equal to 4.87 moles. Now we have got the number of moles of oxygen removed from the container. To find out the mass of the oxygen removed, that is M, mass is equal to number of moles multiplied by the molecular mass of oxygen, that is equal to 4.87 multiplied by, we have given that the molecular mass of oxygen is 32, which is equal to 155.8 grams, which is approximately equal to 0.156 kilogram. So the answer is option D.